Rational equations can take several different forms. If you have one fraction equal to another, it's called a proportion. You can cross multiply and solve it. I'm not going to do that example here, but we'll go through the steps. Anytime you're solving a rational equation, so you have a variable in your denominator, and the first step you can solve this a couple different ways. The most common way is to get rid of all fractions. And you can get rid of your fractions by multiplying every term by the LCD. Okay, so if you take every single term that you have here and you multiply it by the LCD of every fraction in the problem. So here means multiply it by an x minus 1, by a 1, which you don't need to write, and by a 3, which I'll write in front, again, just to make the monomial factor first. So here's our LCD. If we multiply every term of the entire equation by this LCD, we don't change the value, the relationship. And what this does is it eliminates the fractions from our problem. So here we take the numerator of our first fraction, and we're going to multiply by the factor that's not canceled. So it's the LCD factor that's not in its denominator. So the x minus 1's cancel. We have to multiply that by a 3. And we take the next fraction's numerator, multiply it by the LCD factors that are missing from its denominator. It's missing both the 3 and the x minus 1. And then set that equal to the next fraction's, the last fraction's numerator 10 times the LCD factor missing from its denominator. Again, the 3's cancel here, leaving just the x minus 1. Once you do this step of getting rid of your fractions, you can then solve the resulting equation. And now, in this particular case, our resulting equation winds up being a linear form, just like what we went through in the previous section. As we get further into Chapter 5, this resulting form could be a quadratic or another type of form. So you just solve it however the steps suggest for that particular type of problem. Okay, so if we look to solve this, we just get rid of our grouping symbols. The 3 times 3 is 9. Distribute that. Distribute our 10. And so here, as we work to solve this, we move all the variables to one side. So if we subtract the 9x so that we're working with positive numbers, we get x. At the same time, we can add 10. 10 minus 9 gives us a net of plus 1. 6 plus 1 gives us an overall answer of 7. Okay, one of the things that you want to make sure once you're dealing with rational equations, absolute value equations, and radical equations, which we'll get to later, is you have to check your solutions. Okay, for rational equations, usually all you have to check for is to make sure that there's no domain restriction that's being violated. So here, when you plug a 7 in, does that give you division by 0 in this original problem? No, so it's going to work. You can plug it in and actually test it too. If you take 2 over 7 minus 1, which is 6, plus 3, which is 18 over 6, is that equal to 10 over 3? Is 26 equivalent to 10/3? Yeah, just reduce it. 2 goes into 2010, 2 goes into 6, 3. So that checks and verifies that you have the right solution. All right, take just a moment and see if you can come up with a solution to the following. Again, this is sample problem number 2C on page 38. So if you start working through this problem, if you multiply, get rid of your fractions by multiplying everything by the LCD. You need an x plus 1, a 1, which you don't need to write, an x plus 1, which you already have. You don't have to write it a second time. Again, you're looking for the least common denominator, so the lowest number of any given factor. And so now you can distribute this to every single term. So you take the first fraction times the missing LCD factor, not missing anything. Set that equal to the next fraction's numerator times the missing LCD factor, which was x plus 1. Then minus the next fraction's numerator times the missing LCD factor, again, not missing anything. So here's your expression. If you set this up to solve, distributing your 5 through, you can combine your like terms. We get a negative x. In the same step, we can subtract a 5 from both sides. So we get 1 is equal to negative x. Solve for x. Just change the sign of each term, or multiply by a negative. So you get x is equal to negative 1. If you check this back into the original equation, what happens? Does it fit with the domain restrictions of that original form? No. So your answer is, again, going to be no solution. And when you have an answer that you can identify mathematically, but it doesn't fit the domain restrictions of the original problem, that's called an extraneous solution. An extraneous solution results in a no solution as its answer. But you do have to check your solutions when you're dealing with, again, rational equations, absolute value equations, and radical equations.